Today we'll be talking about the present value of an annuity. Now, basically that's the single amount today that's the same value as making a series of payments over time. And that equation for something like that is P is equal to R, 1 minus, yes, I'm making it a nice number 1 plus I raised to the negative n, and bracket, all divided by bracket I. And all the variables that we have are the same meaning as what we used to have in the A values. Now you'll notice that the negative n is there. It means that we're actually going back in time. Now you recall that with annuities we always had this thing that was called the R value. We used to call that thing a residual. And a residual is nothing more than a payment or deposit or withdrawal that happens repeatedly. That's all you need to remember. If it happens a lot, several times over years, then you know that is what we call your residual. Now let's go on to our next problem. Now it says here, a used car is advertised for purchase for $240 a month for approximately 2 years. The interest is 3.5% compounded monthly. Now, the first question asks us what the single payment today would allow us to purchase the car outright. So when we're looking for that, we're actually looking for the present value. So we start with P is equal to R, 1 minus 1 plus I to the negative n, all divided by I. Now, let's go and identify all the important parts. You'll notice that when you look at the problem, it says what single payment. Anytime it says it's a single payment, we're talking about a present value. We're not talking about future value, we're just talking about present value. Now what I tend to do here is I tend to write down all of the variables from right to left. PRIN are the variables. And then what we'll do is we'll identify each of the parts. So you'll notice I got the number 242 and 3.5%. Now what are all of those? The first one, the 3.5%, is just 3.5 divided by 100, which gives us 0.35. Now looking at our variables, P we don't know, but R we do, and that's 240 because that's our repeated value. R stands for the repeated number, otherwise known as the residual. The I value is the interest per compounding period. In this case, we notice that it's months, so we have to divide our interest by 12. And now we have to figure out the n value, which is the number of months in 2 years. So we're going to take 2, and I think what we're going to do is we're just going to multiply that by 12 to eventually get 24. Now please remember this is my remedial video, so all numbers are color coordinated. So in this case we got 240 and the rest of the problems are filled in. R is 240, the interest is 0.35 over 12, which substitutes directly, and now we'll calculate our final answer. And you're going to get $5,555.21. Now, basically what you could say is the following. When you complete your solution, you have to kind of describe what you're doing. So when we're talking about the single payment, you're going to say, therefore, the single payment would be $555.25. So that is what you would do in order to buy this thing outright. Now, I'm just going to take a moment and make sure all my variables are kind of tied together, so when I move the screen, it all sticks together. Okay, now, the next question. Notice we're leaving 555.21 here, and it asks us what is the cost under the payment plan. This means how much money would I pay if I was paying the $250 for the 24 months. Okay? So in essence, we're looking for the total amount of money we put in if we decided to pay the $240 for the 24 months. Does that make sense? Now, when we're going to do this, I'm always talking about the residual and N. So in order to get the total, what we have to do is take the residual R, and we're just going to multiply by N. Anytime we have to do any totals with payments, we always take whatever we're paying each time and multiply by N. So that's 240 times 24. And just remember, it's always the residual times the number, and that gives us 5,760. So, therefore, the total cost would be $5,760. So remember, the total is always the residual times the number of times we pay that residual. Now, when you look at these two numbers, the 5760 and the 5,521 gives us our totals being different because interest is paid on each payment, i.e. the residual. The residual contains the interest. And that's why the totals end up being different. So right now, we're taking a look at another problem. Sarah basically wants to set up a trust fund for her grandson who's currently 16. And we need to know what amount she needs to invest today so that we can withdraw $1,000 on each birthday until she's 25. So that's an annual compounding, right? And the interest in this case is 5.125%. Now, notice the ages. We start with 25 and we go down to 16. So 25 minus 16 is 9, so therefore there's basically 9 years for this problem. And in essence, we're going to basically do 9 years of withdrawals. So now let's go and circle the important numbers. We have 16 and 25, and look, there's also 1,000. Now, that 1,000 is what we're actually withdrawing or pulling from the bank account that the grandmother set up. Now, remember, a residual is something that we're always taking out or always depositing. Now, since it's always being taken out each time, we're going to say that it is a residual, the R value. Now, let's go and take a look at the percentage. Since we have 5.25%, we just have to do this. 5 plus 1 divided by 4, we store the answer, hit equals. Then what you're going to do again to get the appropriate decimal, you take whatever the answer is from that equal sign and then divide by 100. And you're going to get, in this case, 0.0525. Now, that will give us the percentage for the year. So now we know that this is a present value problem because we need to know how much we need to have in our bank account today. Not in the future, how much we have to have in today so that the grandson will take it. So that means it is present value. That is what that big highlight means. So we start off with our equation and then we write down all our variables and we'll fill out the rest of the chart. The R is 1,000. The I value. Remember that the I value is the interest per compounding period. We notice that this was compounded annually. So we're going to get 0.0525 divided by, because it's annually, we're dividing by 1. Now, as for the N value, We can figure out that because we already know how many years there were. We said that there was 9, so we're going to take 9 and we're going to multiply that by 1 to give us 9. And now we substitute appropriately. Now, upon completion, we get the following answer. 7,029.35. So, to answer your following question, all we have to do is we just have to say what we're going to do. So we're going to say, basically, she must put in $7,029.35 today in order for her grandson to withdraw $1,000 every year until he gets to 25. That's it. And we're good. Your homework is online. Good luck.